Hi there, I'm Hao, and this is just another video of me solving random code problem. So we need to write a function to check whether a given integer is a palindrome, not a string, but an integer. And so there's a few edge case that we can eliminate right, even before checking it. So for example, if x is negative, right, then we never gonna have a palindrome because x is negative, right? Because negative 1 to 1 is different than 1 to 1 negative, right? That's how they explain it here. Okay, because x is an integer, so it's not a string, so we never gonna have something like that, right? So if x is negative, or the second case is that if the last number is 0, so if x mod 10 is equal to 0, which is the last number, let's say we have 10, right? And the last number is 0. If the last number is 0 and x is not 0, which means it is not a palindrome, right? Because the only condition that satisfy this, right? If the first and the last number is the same. If the last number, x mod 10, is 0, which means x has to be 0, right? Because it is actually an integer, we're not going to have something like this, right? We're not going to have leading 0. So if the last number is 0, which means x has to be 0 for the number to be a palindrome, right? So that is our two base case, right? So we can just handle that first. So if x is 0, x is negative, right? Or x is x mod 10 is equal to 0, and x is not 10, x is not 0, sorry, and we can just return false. Okay, so if x is less than 0, right, we don't have we know that it's not a palindrome. Or if x mod 10 is 0, but x is not 0, then we also know that that is not a palindrome. So that is two cases that we need to think about. Okay, so we already take care of the edge case. So for the normal case, x would be a positive number. So we're gonna have like 1 to 1. So how would we do this? We can reverse, right? We can turn this into a string and we can reverse it. Or we can just like reverse it using an integer. We can just keep adding uh keep adding x mod 10 to the reverse, right? Reverse equal to 0, right? We can do multiply by 10 plus x mod 10, right? Which is 0, 0 times 10 plus x mod 10, which is 1, right? So we're gonna have 1 here, right? And after that, we can divide it by 10 to get rid of the first number, and do it again, right? Multiply by 10, add 2, which is 12, right? Then divide x by 10, and keep going, right? Till x is 0. So if this number is the same as the original x, right, then we know that it is a palindrome. But actually, we can improve the runtime by a little bit by not reverse the whole thing. So in fact, we can just reverse half of the number. So if it is an odd number, a number with an odd length, so 1 to 1, we can have a condition that when the reverse number, when x is greater than the reverse number, right? And we can keep going. So it will stop when x is equal to 12, right? So 1 first and then 2, right? So now x is no longer greater than the reverse number, so we stop, right? In this case, we want to compare x and the reverse, right? It's either, because if we have the even number, the number with even length 1, 2, 2, 1, right? Then we will stop at 12, right? Which means we can compare either x is equal to the reverse, right? or x is equal to the reverse divided by 10, right? And we can floor that. Okay. For the even number, which is this case, right, x equal to the reverse number when x is greater than the reverse. But if it is if the number have the odd length, then we want to divide the reverse by 10 before we compare, because we don't care about the middle number, right? 2 is equal to 2, so we just don't care about that. Okay, so that is our strategy. So let's code this up. We're gonna have our reverse start. We can start out at 0, and y x is greater than reverse. We can do reverse equal to reverse multiplied by 10 plus x mod 10, right? And we need to update x divided by 10. We float that because we don't want decimal number. Okay, and after that we can return it. So the first case is the number with even length, right? X equal to reverse square, X equal to mod of floor of reverse divided by 4. Okay, and the time complexity would be log of x, right? Log 10 of x, because we are in base 10. Right? We can make the number 10 times bigger, but we only have to go one more iteration, right? We just keep divided by 10. Just like in the binary research, when you keep divided the input by 2 every time. So it would be log x of 10. Okay, so let's give it a try. Submit, and thank you for watching.